densification of the city and the opening up of that potential agricultural space. This is a rooftop farm in Brooklyn, and there are several benefits to having urban farms and more agrarian landscape intermingled with our city. Culturally, it means that we as consumers are more connected to our land, which means we have a fostered environment of conservation and protection. Also environmentally, it means that we're going to have more permeable surfaces in a city that is notorious for just being concrete and having very poor drainage. So to speak more on drainage, storm drains and sewers are effectively the streams and ponds of the modern city. As we all know, the city has a problem with flooding. If we get heavy rains, the sewer mixes with the stormwater and overwhelms the treatment facilities. So as a result, there are 27 billion gallons of raw sewage dumped into the harbor over the course of a year. And that's not good. By increasing the soil and vegetation, having rain gardens like this, and also opening up that potential agrarian land, we could really be able to manage our stormwater in an efficient manner. So why do we care about drainage and stormwater management in the first place? Well, it really has a profound effect on the ecosystem around us. This is a picture of the Hudson River. It used to be a food resource for the Lenape, and I think that we could reclaim that as a potential economic and food resource for the city, because by collecting and recycling water several times through the city ecosystem, we can provide clean water and really is a filtration system and recycling system for the water that we produce. So I want to talk a little bit about blue belts and specifically the role of wetlands in sustainable growth for the city. Through our research this semester, we had identified the huge loss of natural water features in the New York City area. However, the streams from 400 years ago can really influence us in how we move forward in storm water management today. So New York City just recently had a Blue Belt initiative in Staten Island, and that's what you're seeing here. Basically, that means they restored a section of wetlands and streams to drain the area naturally. So that's an image from the project here. By restoring natural drainage corridors, Staten Island has been able to sustainably manage its stormwater and save tens of millions of dollars in infrastructure costs compared to the cost of providing conventional storm sewers on the same land area. So not only do these restored wetlands provide a much needed open space for the community, it also provides habitat, much as Alani spoke to before, for the wildlife in our city. So I want to speak briefly about shelter as well. Buildings are really a prominent feature of the city today, and will continue to be a prominent feature in the city of the future. But as a case study, I would like to share with you a story that really draws attention to the intersection of historical ecology and buildings. So this is the Google building. It's actually the old Port Authority building, but Google just recently purchased it, and it's located in Chelsea. So basically, Google bought this building. It's been great, except they had a problem with their basement consistently flooding, and it wasn't due to rains. The reason being was because there was a stream that was making its way into the basement. So if you see here, this is a picture from the Manhattan website. This stream here and here, going up to the wetlands there, has found it, so it's still part of the landscape today. It's just underground. The new Google building is right around here in Chelsea. So fortunately, instead of fighting this phenomena, Google was able to harness that freshwater supply and use it to cool their servers and sort of data equipment. Sorry, I'm not a computer person, hold on. They're basically their data services. So that's been a really great step forward towards sustainability, and we think it's a really good example of how we can use historic ecology to shape the future. So finally, this is an image from the Welikia project team. Basically, it's just a thought of what a city block in Manhattan might look like 400 years from now in 2049. Streams and native plants would weave their way through the urban fabric. Green energy would be captured where applicable. Pedestrians would reclaim the streets, and cars would no longer dominate the landscape. Rain gardens and green roofs would blanket the city. So, as you can see, the research we've done this semester has a wide range of applications, some of which we can use to really help influence the city of the future. So finally, just to wrap up the presentation, I would like to read another quote from Professor Sanderson's book, Manhattan. By 2049, popular demand for sustainability will have reshaped the landscape to support its 12 million people who will live in a necklace of unique, extraordinary cities on only 36% of the land, surrounded by farms, wildlands, and restored and thriving estuaries. Thank you, and that concludes our presentation, and we would all like to answer your questions if you have any.
How many of you had GIS experience before this class? How many of us had GIS experience before this class? The answer was 4 of us. The rest of us. This is how we divided up the groups. Each group had one of the GIS masters in order to help us while we learned how to use it.
I have a question regarding this densification idea. So, having that many people packed into a significantly smaller space is bound to have other negative ecological side effects, like unlimited sewage, waste management, space, or even social aspects of the increased crime rate. So I'm kind of wondering if you considered like the cost benefit or like kind of balance trade-out between this densification and big space also.
This is the group breakdown. I think this is really sort of a hypothetical situation, but I think the loss of space you might get for a parking lot you would gain in something that would be a community resource that we could all share. That would basically the trade-off would be not a loss of community space, just a growth of community space into something more.
Yeah, I'm really grateful that in the future plans, you spared the neighborhood Queens. The small question is, what happened to Western Queens? Was that last year's group that did that? In Staten Island and the rest of the Bronx?
Staten Island was last year.
Oh, okay. But the bigger question, did you consider using historical records, besides just the maps, people's actual descriptions of particular neighborhoods? Because there's like 158 years between 1609 and your oldest map. So, did you make use of any of that?
Yeah, the first few weeks of our session was actually looking into those resources. We went to a lot of the libraries, the New York Historical Society, and found actual textual descriptions of what people may have found in previous years. And of course, these areas were far less developed than Manhattan in those years. So a lot of the stuff we found was a little later than 1609, but it still gave a very verbose description of what you could have found there.
I'm really impressed with the work that you guys did. It's really very complex and that's really great. And I just wanted to ask about the digital elevation models that you made. Were all of the topo lines in those maps delineated? And if so, do you know what the vertical reference for the elevations was? Is it above the sea level at the time, or what was the vertical reference frame?
was definitely, was different. And we were able to tell, because there were some lines, if I'm answering the question correctly, there were several lines that would be numbered, and we'd be able to tell what each jump of the topo line was. And also there were point elevations at the top of each peak, so we were able to kind of, like in a way, interpolate what the topo lines were. And I'm not sure about your first question, I don't know.
Oh, I just asked if you delineated all of the topo lines and points, and then what the vertical reference frame for the numbers actually was.
We did delineate all the contour lines, and then we used the shoreline, which was at sea level of 0, and worked back from there. And a lot of times the maps had in the legend that each contour line was 10 feet like apart, so every line was ascending in 10 feet. And then when you saw the contour line point, we knew that was 143 feet.
So your results seem to focus on landscape, like streams, wetlands, stuff like that. So I guess I'm wondering, based on what you have now, and then also like anecdotal evidence you mentioned of like the beavers used to live in this area, and then also like current ecological data of what species are around, like how feasible it is and like how much interest there is in